Hi, in this video we are going to talk about the so-called longest path problem and how to implement it with the help of Bellman-Ford algorithm. We have been discussing in the theoretical section that the longest path algorithm can be reduced to shortest path algorithm. We just have to negate the edge weights. And basically, if we negate the edge weights, then the edge weights of course will be smaller than 0, so Dijkstra algorithm cannot be used, so that's why we have to stick to Bellman-Ford algorithm. So basically the vertex will be the same. We have the name, we have the visited, we have a min distance, we have the previous vertex or the predecessor, we have the adjacencies list of edges, basically the getters and the setters, and the toString method. Then we have the edge, as we have seen for Dijkstra algorithm and Bellman-Ford algorithm, with the edge weight, with the start vertex and the target vertex. Sometimes we need the start vertex, sometimes we do not, but anyways, it's going to be here. If it's bothering you, then you can remove it, whatever. Of course, we have the constructor with the start vertex, target vertex, and the weight. And we have the getters and the setters as usual. The Bellman-Ford algorithm is the same. We have to set the source vertex distance to be 0, this is how we initialize it. Then we have to make v-1 iteration. Basically, we relax all the edges, so that's why we iterate through all the edges for v-3 times, where the v denotes the vertex list.size, so the number of vertices in the graph. And of course it is very similar to what we have seen for Dijkstra algorithm. We have the new distance, which is the get start distance, get min distance, plus the edge get weight. So as you can see here, we need this get start vertex. So okay, don't remove it from here. And of course if there's a shorter path, then of course we have to update. So this is basically how we relax the edges. We set the min distance to the new distance and we update the previous vertex or the so-called predecessor. And then we make a final iteration. We iterate through all the edges. And basically if we have a cycle, so the distance keeps decreasing, it means that we have a negative edge weighted cycle. And of course we return. Else, basically, we come to the conclusion that there's the shortest path from the source to the target vertex. We can calculate the total cost, and basically, with the help of this backtracking, so the actual vertex is equal to the actual vertex that get previous vertex, we are able to track the vertices in the shortest path. Okay, so in the application we have many vertices, we have a vertex list, and basically we add the edges between A, B, C, D, E, S and so on vertices. And basically we just have to run the Bellman-Ford algorithm, and because we have negated the edge weights, that's why Bellman-Ford algorithm is going to find the shortest path in this transformed graph, but in the original graph it's going to yield the longest path. Basically, this is the so-called heuristic that we just have to negate the edges. We just have to multiply it by -1, and then we have to run a shortest path in order to end up with the longest path in the original graph. So that's all about longest path algorithm. Thanks for watching.